The focus of this lesson is on composing two functions together. So we are going to start off with our function f of x and g of x, and we're going to take g composed with f of x. And so what that means is you take your outside function, which in this case is g, and you evaluate that outside function at the inside function. So it's g of f of x. So it looks like that. And what that means is g is going to get evaluated at whatever f of x is. Well, f of x is 2x squared plus 3x. So you're used to saying g of x. This is g of 2x squared plus 3x. And so what that means is you need to look at function g, because that's the function you're dealing with, and you need to evaluate x at 2x squared plus 3x. So in other words, wherever there's an x, replace it with the 2x squared plus 3x. So that's what it means to take g of 2x squared plus 3x. Replace your x in function g. So if you do that, you need to go ahead and just distribute and perform your operations, and you get 8x squared plus 12x minus 1, and then you're done. So that's your g composed with f of x. Now, as far as the domain is concerned, we're going to do the domain of g composed with f. So the same composition, the same function g, and the same function f. And we want to know what the domain is. So whenever you're talking about the domain, you have to consider two things. You have to consider the domain of the inside function. So in this case, we need to consider the domain of f. And then you also have to consider the domain, or it's not really the domain, but what appears to be the domain of g composed with f. I mean, that's what we're trying to figure out at the end of the day, but that's what we're going to look at, is just looking at g composed with f without too much thought. So first, for the domain of f, we would look at function f. So f of x is 2x squared plus 3x, which is just a quadratic or a polynomial. And the domain of those are always all real numbers. So the domain is all real numbers. In other words, no matter what value you put in for x, whether it be a negative number, positive, zero, fractional, decimal, rational, irrational, no matter what you put in, you will get a real value back. You don't ever run into anything that's undefined or something that you can't compute. So we would say that the domain in that case is all real numbers. Now, keep that in mind. That's not the domain of g composed with f. Now we're going to go ahead and look at g composed with f and what appears to be the domain of g composed with f. So g composed with f is 8x squared plus 12x minus 1. Again, it's a quadratic or polynomial, and no matter what x you put in, if you square it, multiply it by 8, and then you take that value and multiply it by 12 and then add those two together and then subtract 1, no matter what, you're still going to get a real number back no matter what you input. So everything works, and so we would say that the domain is all real numbers as well. Then what you do is you put these two ideas together and you look for where these domains overlap, so that basically their intersection. But all real numbers and all real numbers overlap at all real numbers. And so the domain of g composed with f is in fact, for real, all real numbers. So that is truly what the domain is. So this is just one example of composition and finding the domain of a composition. But that's the process that you would follow.